Welcome pre-calculus students to class today on Tuesday the 29th. I'm sure I'm sure you're depressed to be back today. I hope you've had a nice fall break. I was talking to Caleb a little bit. I know he said that his other classes were not on a fall break, so I guess probably most of you did not have a full fall break, but at least you had pre-calculus off for a week. So in spite of your depression, welcome back to class, and it's good to get back to work again. A couple of announcements. We will have a quiz this weekend, and so make sure you're prepared for that. We'll go over more in detail as to what will be on that quiz, probably on Friday. I'm changing the rule on the integrity sheets, and I want to warn you that you're not going to like it, but there just has to come a time, guys, where I'm not holding your hand so much and giving you so many chances to get things turned in. And plus, again, I really feel like homeschoolers, and I have no hesitation to say this because we homeschool our kids, so I really feel like I know where homeschooling is weak and where it's strong. And one thing where I feel like, at least with my kids, I'm weak is really teaching them to be accountable on a daily basis. And men, if you were in a school somewhere, you would be sitting in pre-calculus every day for 50 minutes. And then on top of that, you would have homework every night, probably at least 30 minutes of homework. Now, I do try to go a little lighter than that. But my point is, on the integrity sheets, what I'm about ready to tell you is really nothing compared to what a normal high schooler would go through. They would have to turn their homework in the next day. So if I really wanted to be tough, I would make you guys email me every day saying, yes, I completed everything, or no, I didn't. The reason I don't do that is I want your families to feel like they're in control and not me, because you do homeschool so that your families can work through different situations, schedules, whatever. So that's why I don't do that. I want to respect the fact that your mom and dad are your final authority, and that you homeschool. But one thing I am going to say from now on, when you show up on Mondays, if you don't have your integrity sheet with me, I'm not giving you credit for your homework. Now, in all fairness, I'm going to remind you every day, okay? Because what's happening is I'm emailing some of you. Actually, one student I have yet still to hear on whether or not he did all of his homework. And so you understand, I'm not angry. I'm just working a little harder than I'm probably supposed to, when in reality it's you guys' job to be doing this. So from now on, when you meet at my house on a Monday, you're going to hand me a sheet of paper that has every single day that we had an assignment. You're either going to have, checked yes, you did it, yes, or no. And I'll remind you every day. So I'm not saying you have to stay on top of this every day. If you get a couple videos behind, that's between you and your mom and dad. However, let me say this. When you come into class on Monday, you are going to have those with you from now on. So please stay on top of those. I still need test number 5 from some of you. Some of you have made arrangements to visit with me, and that's fine. Others are still trying to get it to me, so please get that in as soon as possible, okay? So those are the announcements, and let's jump right into it, men. Let's jump right into it. Grab your notebooks, grab your pens, pencils, calculators, books, and let's have a great day today. Here we go. We are going to start looking at something today, men, called solving trig equations. Now, the lesson number is lesson 6.5, and the date today is the 29th, 10/29/13. Okay? Solving trig equations. Now, I will tell you when I want you to write something down, these next couple of sentences you do not need to write down. I'm just going to say some things to you here, so here we go. We are going to spend 3 days studying trig equations, all right? Today, we're going to start off with some very easy basic equations, all right? So today, very easy, very basic. Tomorrow, we are going to look at solving, or look at how to solve difficult, complex trig equations, okay? However, we will not have homework tomorrow. So it's going to be a pretty long video, a lot of problems, but no homework. On Thursday, I will not teach you anything new. There will not be any notes to take. You will have homework only that will cover Wednesday's notes. Okay? So hopefully all of this makes sense. So really easy basic trig equations today. Tomorrow pretty difficult, a long video but no homework. And then Thursday no teaching video, but there will be homework Thursday. All right, let's continue on. I do want you to write down this concept that I'm going to put up here in 1 second. As we get into solving trig equations, you need to understand one important concept, and here it is. Write this down. Trig equations have an infinite amount of solutions. Trig equations have an infinite amount of solutions. That means the solutions go on and on and on. Okay, you could have as many solutions that you would need. This is a real important concept to remember. Let me demonstrate. Take some good notes on this. So write this in your notes, please. And then write down this demonstration. Write down this trig equation. The tangent of x equals 1. The tangent of x equals 1. Now don't confuse that with this. Remember on the test, we learned tangent inverse of 1 would mean to write it like this. Tangent of some angle x equals 1. And yes, would you please look carefully? They're the same. I understand that. But here's the difference. Please listen to me carefully. When the problem is written as an inverse like this, remember we know automatically tangent is confined to these two regions here, quadrants 1 and 4. But whenever it's just a trig equation, it's not confined to just two quadrants. It can be any quadrant we want, so that's the difference, okay? So here's a trig equation, tangent of x equals 1. Now, basically what I'm looking for is an angle so that when I take the tangent of that angle, I get out 1. So let's go back to our handy dandy table we've always used before, and here it is. Let's see, here's tangent. When do I get out a 1? Well, it looks like to me when I take the tangent of 45 degrees, I get out 1. Do you see that? Tangent of 45 would give me 1. Now, watch carefully what I do. Just watch how there's infinite amounts of answers, okay? First of all, we know tangent is positive here, and we know tangent is positive here, because the sine sequences go like this, 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 and this. So we know tangent is positive in the first quadrant, and tangent is positive here. Now let's go back a page. Remember, the tangent of what gives me 1? The tangent of 45 degrees. Now, I'm going to go ahead and put 45 degrees here in this triangle, all right? Then I'm going to go to quadrant 3. I'm going to put 45 degrees here, all right? Now, of course, here, the angle is 45 degrees. So I'd like you to write that down somewhere in your notes, okay? And now watch this. Now, I'm going to rotate all the way from here to the hypotenuse of the other triangle. So that would be 180 degrees right here, plus 45 more, so 225 degrees. Now, with your calculators, go ahead and type in the tangent of 45. And when you do that, you're going to get 1. Now, with your calculators, go ahead and type in the tangent of 225. And yes, guess what? You'll get 1. Now, there's 2 answers. Now watch this carefully. See this one answer here, 45 degrees? And see this one answer here, 225 degrees? I want you to add 360 degrees to this. And when you do that, you'll get 405. Now take the tangent of 405, and guess what you're going to get? You're going to get 1. Now add 360 again. And you get 765 degrees. Now take the tangent of 765 degrees with your calculator. Yes, you get 1 again. So far, here's one answer, here's one answer, here's one answer, here's one answer. All of these angles work. If you take the tangent of this, or this, or this, or this, you get 1. Let's add 360 to this one here, and we get 685. Go ahead and take the tangent of 685. and you'll get 1. Now add 360 degrees again, and you get 1045 degrees. Take the tangent of that, and you'll get 1. And we could keep adding 360 over and over and over and over, and we would keep getting answers. And that's why trig equations have an infinite amount of solutions. Do you see that? Okay? So I wanted to show to you why that is true. Now, you say, well, Mr. Earhart, if that's the case, then how are we going to be able to find answers? Well, here's what we do with these types of problems, okay? What we do is we say, okay, the answer is 45. Not sure what happened there. Well, there we go. Okay, the answer is 45. So what we do is we say, okay, the answer is 45. Now watch carefully. Plus, now watch, 360k. And there's one answer. I'll explain why in just a second. Then over here we say the answer is 225 degrees plus 360k. Now here's why we do this. Watch. K is how many times you add 360. So what you're basically saying to me, and you can just memorize this if you need to, okay? You don't have to thoroughly understand this. But what you're saying to me when you write these two answers is, one answer is 45, plus I can add 360 k times, or as many times as I want to, over and over and over, and I will keep getting out answers. And then over here you're basically saying to me, the answer is 225 degrees. And that's an answer, but I can also add 360 degrees to 225 k times, as many times as I want, and I will keep getting out answers. So that is how we write our answers, and it kind of covers that dilemma of how many answers are we going to write. Now, in your homework tonight, I also want you to write your answers in radians. So for radians, you would put pi over 4 plus, and then you would not use 360, you would use 2 pi k. Because remember, students, 2 pi in radians is 360 degrees. So do you see what I did there? Instead of using 45 degrees, I use pi over 4, which is radians. And then if it's in radians, you're not going to add 360 degrees, you're going to add 2 pi. And then k, of course, means how many times you're going to go around. Now, I've not converted this one yet over to radians, so I'll do it over here real quick. 225 over 1 times pi over 180. Let's see, 5 would go into both of these numbers. 45, 5 would go into it. 36, 9 would go into this 5 times, and 9 would go into this 4 times. So it looks like we would get, if I didn't make a mistake over there, it looks like we get 5 pi over 4 is the same thing as 225 degrees plus 2 pi k. That means you're going to add 360 degrees or 2 pi k times over and over and over. Okay? So this is your answer written in degrees, and this is your answer written in radians. All right? Now let's go ahead and do 2 problems, and that's it. I'm really starting off light on you guys today. Your homework is only 8 problems long, and I'm only giving you 2 problems in your notes to work on. Okay? Go ahead and write this problem down, please. Tangent of x equals negative square root of 3 over 3. This is a simple trig equation. Now, we're trying to solve for x. So let's first of all find an answer in degrees. So I'm going to go to my table real quick, and I'm going to say, when does tangent give me square root of 3 over 3? Right here it is. So the tangent of 30, or pi over 6, gives me square root of 3 over 3. So let's go back a page. So the tangent of what? 30 degrees, or pi over 6. There's my answer, but hold it. Notice I want to get out a negative square root of 3 over 3. So that means I'm going to have to go to the 2 quadrants that tangent is negative, not positive. And here, tangent is negative, and here, tangent is negative. So I'm going to draw my triangle here, and I'm going to draw my triangle here. I'm going to go ahead and put 30 degrees in here, and I'm going to put 30 degrees in here, okay? Now, My 30 degrees has served its purpose, so I'm done with it. There we go. And now watch. Remember, you always start here, and you always go to the hypotenuse. So I'm going to stop right here at the hypotenuse, okay? So how many degrees is that? 150. So one answer is 150 degrees. There's one answer, 150 degrees. Now I got that because, let's go back a page. Remember, or let's go forward a page. I knew that the tangent of 30 is square root of 3 over 3. And so I knew I had to put 30 inside this triangle and 30 inside this triangle. Notice I also went to the quadrants that were negative. Okay? So 150 degrees plus 360k. There's one answer. Now let's also write this in radians real quick, okay? And I'm going to do this, I think, quickly in my head. It should be, I believe it's 5 pi over 6 if I converted that to radians correctly. Let's see, 150 over 180, 0. 3 would go into this, 5 and 6, yes. 150 degrees is 5 pi over 6 plus 2 pi k. That means you could add 2 pi over and over and over k times. Now that takes care of this quadrant. Now let's work on the fourth quadrant. So I start here and I go all the way around until I get to the hypotenuse, which is right there. So from here to here is 90, from here to here is 180, from here to here is 270. Now it looks like basically like this. Look at it like this. If I would have gone all the way around and not stopped here, but gone all the way to here, that would have been one whole revolution for 360 degrees. But I stopped 30 degrees short, so I really went around 330 degrees. So there we go. 330 degrees is my answer. Plus, we always add 360 degrees k. And now let's go ahead and convert this over to radians real quick. I believe it would be 11 pi over 6. Now I did that in my head, but I'm pretty sure that's correct. Plus 2 pi k. So there we go. Let's try one more and then we'll get started on your homework. Cosecant of y equals square root of 2. Cosecant of y equals square root of 2. Let's look at our table real quick. Here's cosecant of 30 or pi over 6 gives me 2. Cosecant of 30 or cosecant of pi over 6 gives me 2. So I'm going to go back a page. Well, I want square root of 2, don't I? I apologize. That's a mistake. Looking for square root of 2. So cosecant of 45 degrees or pi over 4 gives me square root of 2. Cosecant of 45 degrees or pi over 4 gives me square root of 2. So I'm dealing with 45 degrees. Now notice I want a positive square root of 2, so I have to go to the two quadrants where cosecant is positive. Now cosecant is the inverse of sine. So wherever sine is positive, cosecant will also be positive. Well, sine and cosecant are both positive here, and sine and cosecant are both positive here. So here's the two quadrants I'm going to be dealing with. So I'm going to draw one triangle there and put 45 degrees. I'm going to draw one triangle here and put 45 degrees. Okay? Now let's start with the first quadrant. I always start here and go to the hypotenuse. So there we go, 45 degrees. So one answer is 45 degrees plus 360k. And then if I wrote that in radians, 45 degrees is the same thing as pi over 4 plus, I'm not going to add 360, but instead I'm going to add 2 pi k. Now that takes care of the first quadrant. Now let's deal with the second quadrant. I always start here and I go to the hypotenuse, so I go all the way to here. Now remember, if I would have kept going all the way to here, that would have been 180 degrees. But I stopped 45 degrees short. So from here to here is 135 degrees. So there's one answer, 135 degrees plus 360k. And then let's change 135 over to radians. That would be 135 over 180. Let's see, that would be 5 would go into that. 227 and 180 would be 36. And then let's see, 9 would be 3/4. So the radians for this would be 3 pi over 4 plus 2 pi k. Now I'm assuming, students, you remember how to convert degrees to radians. I'll do this for you real quick just to make sure. Remember, you always take the degrees and you multiply it by pi over 180, okay? Now when you do that, what I realized here is that I believe I reduced by 5, which would be 27. I reduced by 5. That would be 36. Then I reduced by 9, and that would be 3 and 4. So 3 pi over 4, okay? So there's your answers. So in my opinion, these are pretty basic, easy trig equations. You simply figure out the angle that will give you out this here, and then you find the two quadrants you need to work with, and then go from there, okay? So it's really not too difficult. I would like you to try these 8 problems in your homework. Page 588, numbers 1 through 8, okay? So this is due tomorrow. I mean, if you were in regular school, due tomorrow. So please go ahead and get working on this and use the help video if you need to. But page 588, numbers 1 through 8, please don't hesitate to call me or email me if you have any questions.